Hey, topic in life math industry, and we are gonna think and deduct for a bit. So in geometry, you probably heard about those proofs that we've been solving in the last few videos. And if you ever watch those videos, you realize that those proofs have to take a lot of thinking, where you have to think and think and think. Well, in geometry, there's a lot of thinking, and there's a lot of deduction and reasoning, because you'll have to prove your answer instead of just answering it and be done with it. So, there are two things that we are going to look at today when it comes to thinking and reasoning. There is condition statements and there are negations. So these are one of the most common reasons or common pieces of evidence to back up your theorems and to back up your proofs. Let's start with conditions. So when you do condition statements, you probably heard of if-then statements. Like, if this happens, this will happen. If that happens, that will happen. Well, that's what a lot about conditions are, is there are a lot of if this will happen, then that will happen. So we're going to say if A, then B. That could be an example of an if-then statement, because A is represented as the hypothesis, and B is represented as the outcome or the conclusion. So here's an example. Okay, so here is an if-then statement. If Mario touches those fireballs, then he'll take damage. Watch! So it does make a lot of sense how there's going to be a lot of if this, then statements with geometry. Also, with condition statements, we sometimes have to make it a converse, which means you get to switch the values up. So, if we originally said if A, then B, then we could say that if A brings you to B, the symbol right here is called it brings you to B. However, if you wanted to find the opposite or the converse, then that means that both of the outcomes or both of the events will be switched around. So that would say B would bring you to A. So condition B will bring you to condition A. To make this better understand with this video, then here's another example of a converse that might work. Okay, so here's the example. If Mario jumped to collect these coins, and he did, the converse would be that the collected coins would be collected by Mario if he jumps. So we're having two things. The equation is Mario jumps, then collects the coins. The converse would be Mario collects the coins if he jumps. Let's see what happens. Okay, so that was a great example of how we can have an equation be turned into a converse. However, what happens when you can't inverse it? What happens if you try to, but it won't work? In that case, here's an example where it would not work, where condition A and condition B cannot be swapped. So, if this is Mario, then he's wearing the color red. But the thing that cannot work is if he's wearing the color red, then it has to be Mario. The reason why it would not work is because we said that if he's Mario, that means it can bring us to the color red. But how does it work when the color red can be brought to Mario? This is not gonna work because anyone else in the world is wearing the color red, like a red t-shirt, or red this, or red that, or a red helmet, or whatever it is. So this is a little bit, it's not gonna work because even though Mario does wear the color red, the first condition or the first equation is true. The converse is not gonna work because anyone in the world could be wearing red right now. Maybe you. Type in the comments below if you're wearing the color red. To make this in mathematical perspective, with a converse that will work, we can say that a right angle is going to equal 90 degrees. We could also say that 90 degrees can equal to a right angle. So we have been looking at how with a condition statement we could have A and B if-then statements when a converse does work and when it does not work. Let's look at what else we have to learn about. And what we have to learn about is called a negation. Okay, so let's look at a negation. So a negation happens that, let's say that P can bring you to the condition of Q, but a negation happens when something tries to stop it, like the negation of P.
I still believe in my cards. I draw. Lava Golem's effect activates! I can still turn this duel around. Time to battle. Here we go. I attack your life points directly! I don't think so. I activate a face-down card. My trap activates. Impossible! No! I wouldn't have been victorious had it not been for the help of my cards and my...
So when you have a negation, it usually stops something from happening. And that is basically what negating something means. It's trying to cancel something when it happens. So with a negation, let's look at the converse. The converse is, you know how P is going to bring you to Q? We're going to say that Q is going to bring you to P. That's a converse. And inverse is going to be the cancellation or negation of Q is going to bring you the negation of P. And what else is, we're going to get another separate sheet of paper because this is what we're going to learn next. A contrapositive. This happens when you make both of the conditions the opposite, but it does make sense because you can put it in converse. Like when we say, if Mario jumps, we can collect coins. However, a contrapositive is acting a bit more negative, and not only that, it's still in its converse form. We could say that Mario does not jump. Oh, there are coins up there that aren't collected, that are not collected. And we can also say that Mario does not jump. So a contrapositive is the opposite of a converse, but however, it is still true. Here's an example. So, you know how we said that if Mario jumps, he collects the coins? Well, a contrapositive would be if the coins were not collected, then that means Mario would not have jumped. The word contrapositive does make sense because you have parts of the word converse which make the opposite, and positive because it's making both statements true. And that is how we can understand to think and deduct in geometry. We learned about converse, a condition, if-then statements, a negation, and a contrapositive. I hope this video has helped you. Thank you for watching Topping Your Life's Math Industry. Like and subscribe. And if you ever look back in the video, there is an Easter egg. If you found it, type in the comments below and also research it online.